So you'll have and it's 2 digits, right? No?
3.
And it's 2 digits. Now the way to think about this is that, there are too many such numbers. You try to simplify your thinking into something manageable. Obviously, you look for the extremes. Naively, you say, in 3 digits, how small can it get? What's the smallest 3-digit number? 100, right? How big can it get? 9, yes. And say similarly, yeah. And let's go 9. Now, so you look at this. This times this. The worst case scenario is this times this. That gives you 1,000. 1,000, right? 1,000 is how many digits? 4. Right? So, even when n and n are smallest, the product is 4 digits. You can imagine that if n and n not the smallest possible, then it's at least 4 digits, correct? Never mind this detail, right? That's correct. What about this times this? Now, this is I know where some of you use calculators. That's natural. Don't worry, right? But you can make a rough estimate. Well, 999, that's too hard. But 1,000 times 100 is not too hard. 1,000 times 100 is what? 100,000. Is that 100,000?
Yeah, 100,000.
So this is 40, right? So with the 100,000, 100,000 is how many things? 6 digits. But they're not that big. And it can never be that big. So it should be smaller. If it's smaller, if it's something smaller than this, how many digits does it have?
5 digits.
Why?
That's only
the smallest digit number.
Yes, in the process of counting, how do you graduate to 6 digits? After you have exhausted the 5-digit numbers, right? Therefore, you know anything smaller has got to be 5 digits. Right? So you expect that this is 5 digits. So naively, you know that that's a range. Right? So that's the reason you would make that guess. But now we want to make it precise, right? That's a good guess. How do you explain it? So what you want to say is what? So let me recall, of course that's the reason why I did this. Number this thing, n less than n, and a n and less than a n. Why is it when and what? There is a n and, no, I use k. Remember this morning? For k and n are non-zero whole numbers. Remember this? We're going to use that. So what I want to say is that if 100 less than n, 10, not n, 10 less than n, we want to say that these imply, now this is the simple to say implies. Meaning on that, I can use it to deduce something else, right? Is that 100 times 10 is less than n times 10. So is that true? You believe this. Everybody believes it, right? What we try to do is not to believe, but to explain. Right? Now, remember how we explained this. This should be obvious, right? This is in terms of triangle, the area because whatever. So your students believe this. If they believe this, then you can use it. So how we do this? Well, okay. 100 less than n. Now, of course, adding the equal sign to it. Oh yeah, I never explained this, did I? This means not, that's less than, right? That this is either less than or you allow for equality. I think maybe I never used the book either. I was very careful with the book. Standing in the book like this. I did you? Oh, I did. Okay. So you have no problem with this, I hope. Now you be careful. This symbol, all right. You object to this? Is that okay? Sure. Don't think it's good, huh? No. Why do you think it's good, money?
Well, because I know that 5 does not equal 7.
Right.
So why would it?
But you think it contradicts it? What does it mean? What does symbol mean?
The symbol, doesn't the symbol mean is less than or equal to?
Yes.
So is the or the one that controls here? So it's less
Oh,
than.
doesn't matter who controls who. Right? All I say is that it says that 5 is less than or equal to 7. Right? You think it's correct or not? You think it's wrong? Tell me why it's wrong.
Well, the only question is the or, right?
It's ordinary sense of the word. You don't think 5 is either less than 7 or equal to 7? You don't think that's right?
I'll go with that then, yes.
Yes?
Yeah.
Yeah. So another person objected. Who was it? Everybody else now agree?
We vote.
Huh? Oh no! You don't get to vote on this. Mathematics education is not a democratic process. Right? So I say true, not true. You don't put it to vote. So now, does everybody agree to this? Because look, you may not think it's very sharp, right? This guy's robbery. Right? That's all right. Still a valid citizen of the United States. He can get to vote. I'm not saying this is wonderful. I'm just saying it's true or not true. There's no valid judgment. So it's true. It's true. You agree?
Yes.
Okay. So that's why I wanted. This is very slippery. The people you always, and not you, freshmen. Yeah, freshmen always object. Oh, no. Well, yes. So everything you say here, obviously, with the added equal thing is the same. You see that, right? So, okay. So with this, given this, right? Therefore, 10 times 100 less equal to 10. No, I'm sorry. Yeah. This implies that n times 100 is less than or equal to n times n. Okay? I'm using this now, right? If this is true, I multiply left and right by the same number n. I get this, right? Okay? Alright, now this is not quite there yet because I don't want to say n times n is bigger than or equal to 100 times n. What do I want to say? N times n is bigger than what? 10 times 100. 10 times 100, right? That's what I want. That's what is it? Yeah, this is what I want. Yeah. This is what I want. And this is not there yet. Not to worry, because if you get this idea, you can complete it. How so? Yes?
Because n is bigger than 10,
Very good.
so putting 10 there will cause the product to be even smaller than it already is. So for n times 100, if you replace n with 10, you've created a smaller product.
Good. Right. Except that we can say that. Can you say that? You see, when you say that way, with young kids, do you think they really catch everything you say? They have vague sense, right?
Like 10 times
The thing you will try to do is, even when you think it's correct, you ask yourself, does it leave room for wiggling? Does it leave room for misunderstanding? The best is to say something that no matter what they think, they have no wiggling room. You make it pin down completely that even if they don't understand now, if they follow what you say, at the end they say, yes, I understand. That's what we try to achieve. So what you say is entirely correct, but I'm trying to point out that at this stage, we can learn to be a bit more precise. I'll translate what you just said. All right? If this is true, I multiply both sides by 100. Correct? First of all, you agree with this. Do you all agree with it? What am I using? Same thing, right? I'm using it twice. I'm using it twice, right? If you have an inequality, multiplied by same number on both sides, the inequality persists. Right? But now, what do you see? This number here, this number here, right? This less than that, and that less than that. On the number line, that's perfectly clear what it says. This is to the left of this. This is to the left of this. For sure. This is to the left of this. Let me repeat. Right? So I'm putting two things together. Oh, man, I think I can draw it for you. This tells me what? This is 100 times 10. This here is 100 10, correct? That's what this says. Right? This leads to this. What about this? This says what? This number, which is here, to the left of, and that's it. So look at the picture. What do you think? It says what? Together, right? So together, we get an n of 100 times 10 is less than or equal to n n. Good. So then, I know you multiply two such whole numbers, it's at least as big as this number. This number is 4 digits, right? This is the number 1,000. 1,000 is 4 digits. 3 zeros by 4 digits. So a number that's bigger than a 4-digit number, how many digits can this number have? A number is bigger than a 4-digit number. Number k is bigger than or equal to a 4-digit number. How many digits can k have?
Then the largest 4-digit number, or than any?
No, any 4-digit number. If a number is bigger than or equal to a 4-digit number, number k, how many digits can k have?
4 or more.
4 or more, right? 4 or more, because That's the process of counting. That's how you count. You exhaust the 4-digit number, then you go on to the next round, which is 5, and then 6, and so on, right? So it's at least 4 digits. You cannot go back. There's no going back. If it's bigger, then it's ahead of a 4-digit number, and you go look ahead from a 4-digit number. You know, 4-digit number, look ahead. Everything is at least 4 digits, 4 or 5 or 6 or 7. So you know, you take a product, this guarantees you it is at least a 4-digit number. Right? You handle the low end. Now you handle the high end. High end says what? M, and then you go 999, right? 9, right? And I said, we don't want to handle that one. We want to say this is less than. And is less than equal to 99. And we don't want to handle that one either. It's just okay. Now I don't think I have to repeat myself. I know that MN is less than you agree. The example is the same reason. You agree? I don't need to repeat myself now. Right? Same reason. Good? So now I ask you again. If a number, never mind what it is. It's not two numbers, one number. That number less than, or what is this? 100,000. If a number less than, this is less than, don't forget, less than 100,000. What can that number be? One thing you can say. What? 5 digits or less, right? Why is that? Can someone articulate it? Why is that? Why is that? One time? Someone one time? Yeah, the other time?
Because that's the smallest 6-digit number,
That's the smallest.
and it can't be that big. So
Now you're less than it and you're not looking forward. You're looking back. You're taking backward step. Backward step, what would it be? That's the first 6-digit number. You go back, you start with 5 or 4 or 3 or 2. But cannot be 6 digits. So it cannot be fewer than 4 digits. Cannot be more than 6 digits. What do you think it is? Either 4 or 5. Right? Can I go? But you understand what I'm trying to do. But you don't just say, well, roughly that. Okay. Everybody can say that. But to be able to explain it in complete detail without appealing to your students' goodwill. You always think of your student as your enemy. You have to. That's why you have to be always on the defense. Make sure you don't give them any excuses for not listening to you. That's a good mindset. You are in hostile territory, and therefore everything you do must be completely airtight. That's the mindset I have. What? Right now, for example. Oh yeah, otherwise why should I be careful? Oh yeah. Why do you want to be careful if you're not an enemy higher parent? Right? Amongst friends, do something wrong, oh yeah, it's okay. You teach like that, oh no, not in mathematics. Right? can't do that. Because in friendly territory, you make you make a mistake, they excuse you and say, "Oh, we understand." And in the next line, you may have a class like that, but not this line. You never feel that way when you teach? I feel you're not.
I'm always after you.
Well, that's my only contribution to your life, that's all.